This example reads, suppose water is flowing into the container at a constant rate. Make a rough sketch of the water level Y versus the time T. All right, so they want me to make a rough sketch of the water level Y versus the time T here, okay? All right, so what's the water level? 1, 2, and 3. As I pour water in here, it's going to rise up this flask, okay? So 1, 2, and 3. All right, I don't know what the time is. It doesn't tell me what rate. It just says constant rate and so forth. All right, but what's going to happen is if the vessel is shaped like that, the water level is going to be slow rising. Then it's going to do what about it too? It's going to start rising a little quicker because of the shape of it, right? So it's slow to rise up till it gets to 2, right? Because it's what? Widening right there in my vessel. And then after it gets to 2, my vessel's narrowing, so it's going to slow down. But my water level's increasing the whole time. So I need to draw a function that's increasing, but slower to rise till it gets to 2. Then it starts speeding up after 2. Well, maybe it looks something like this. Slow to rise. Let me draw that a little better. Slow to rise, but once it gets past 2, it starts increasing how it rises. Draw a smoother curve to that. All right, so notice the water level is increasing the whole time, but slowly increasing at first, then it speeds up. What do we notice about at 2 right there? Kind of looks like my concavity changes from down to up, or an inflection point. How about this one? Draw a graph of the water level Y versus the time T. All right, let's see. We got 1 on this vessel and we got 2. So what's going on with this vessel? Try to put those the same distance apart at least. All right, so what's going on with this vessel? Water level rises, but it keeps slowing down as it rises, right? So I'm going to say the water level rises, but it keeps slowing down as it rises. Something like this maybe, okay? Notice how it's increasing the whole time like the water level, but it's slowing down at the rate at which it's increasing. All right, and lastly, I want to look at these figures here, okay? And let's suppose I have a graph that does something like this. Y is equal to f of x. Let's just say that's an x-axis, that's a y-axis, okay? Would y'all agree that this graph is increasing? Well, let me ask you this. What is f prime? Is it positive or is it negative here? F prime is the slopes of my tangent line. They're all positive here, right? How about f double prime? I'll tell you what, let's do this. I got this in my notes this way. So let's say instead of positive, we'll say it's greater than 0. How about f double prime? Is it greater than or less than 0? How's this thing concave? Up. So it's greater than 0. How about if I look at a graph of something like this? Let's look at f prime and f double prime and figure out if they're greater than or less than 0. F prime is the slopes of my tangent line. The slopes of my tangent line are all positive, so I'm going to say that's greater than 0. How about f double prime? That's the concavity, which is down, so that should be negative or less than 0. All right, we're going to look more at that later on in chapter 4.